Good morning, everyone. So yesterday we went over solving linear equations. Today we're going to be looking at systems of equations, meaning we're going to have two equations and we're going to be solving them. So our topic of today is solving systems of equations algebraically. Our learning target. Today I can solve systems of equations algebraically by using substitution. So we're going to be solving these systems of equations using the substitution method. The first problem, use substitution to solve the system of equations below. So we don't have our reference charts here, so we're just going to go based on what Ms. Price said. So first things first, you want to make sure one of your equations is written in the form y equals mx plus b. I see the top equation is written in the form y equals mx plus b. So I'm going to take this y and substitute it in place of this bottom y here. Meaning I'm going to take 3x plus 1 and replace this y with it. So I will have 4x plus, since this y down here has a coefficient of 2, I'm going to take this 2 and multiply it by everything. So it'll be 2 times 3x plus 1. And then I bring down my equal sign and I bring down my 12. So we went over these types of equations yesterday using DCIS. First, we have to distribute the 2 into the parentheses. You get 6x plus 2 equals 12. And then you get plus, and then you bring down your plus sign, you bring down your 4x. Next, I see I'm done distributing, so I'll combine my like terms. I see on the left side 4x and 6x are like terms because they are both variable terms. 4x plus 6x gives me positive 10x. I bring down my plus 2, bring down my equal sign, and I bring down my 12. I'm done combining like terms because I don't see any like terms on the same side of the equation, so I move on to inverse operation. Remember, the purpose of this step is to have our variable terms on the opposite sides of our constant. So I want to take this 2 over here and bring it to the other side. So the opposite of adding 2 is subtracting 2. So I subtract 2 from both sides. These eliminates because they're additive inverses. I bring down my 10x, bring down my equal sign. 12 minus 2 gives me 10. I'm done with inverse operations. So my last step is to solve. When we solve, all we have to do is divide our coefficient. Our coefficient is 10, so we divide 10 on both sides. And we are left with x equals 10 divided by 10, which is 1. So we know that x equals 1. And we also know that y equals 3x plus 1. So now all we have to do is find our y. So we're going to take this x, which is 1, and substitute it in place of this x down here in the equation. So we have y equals 3 times 1 because we're replacing our x with 1. And then bring down my plus sign, and then I bring down my 1. And then 3 times 1 gives me positive 3. Bring down my 1. And then I bring down my y and my equal sign. 3 plus 1 is equal to 4. So we have y equals 4. So remember, guys, when they're asking you to solve a system of equations, they're asking you for a specific point where the two lines will intersect. So we want our answers to be in the form of an ordered pair. Ordered pairs always come in the form x comma y. So our solution to the systems of equations is the point 1 because our x is 1, comma 4 because our y is 4. That's our solution. And here goes your problem 2 of the day. Take a screenshot, jot it down, solve it. You know what to do. Bye.